Hello everyone, welcome to Linked Frequency. I am Vaibhav Sugandhi. In this particular tutorial, we are going to talk about the basic syntax of Arduino IDE and also certain instructions which we have to learn as a basic level of programming. We are going to talk about how exactly the programming syntax in Arduino IDE, and also we are going to talk about the 7 different instructions which are very essential for you to learn before starting with Arduino development board or Arduino projects that you wanted to do in your future. Without wasting a time, let's get started. Great, I am back with mind map in front of you, which helps us to understand the concept of today's discussion. So whatever we are discussing today, I am bringing in front of you as a mind map. So today we are going to talk about that syntax and also certain instructions, like 6 to 7 different instructions. Along with that, I just wanted to cover a couple of things, which is all about history about Arduino, like how Arduino started and who started it and all those things. Thereafter, we are going to discuss about the syntax and also we are going to discuss about instruction, and lastly, we have a couple of assignment to you. I hope you enjoy this tutorial and also you do the assignment at the end of this particular tutorial. First of all, let me talk about the history of Arduino as a company. Okay, first thing first, Arduino is not a controller nor a processor. It is an development board, which I spoke about this particular sentence a lot of time previously in these few tutorials which we watched so far. But do remember this one, guys. This is the most important fundamental knowledge you must carry out from this entire tutorial series or maybe entire course that we are hosting on this platform. Okay, and thereafter we must remember that Arduino is a company name based out in Italy actually, and it is a wonderful story is there behind this name called Arduino. It is a bar and restaurant name in Italy. So if you are really interested to understand the story behind it, do remember lastly we have a 2 assignment. Watch until that particular assignment and complete that assignment. I'm very sure you enjoy the entire process. Okay, so founder of this Arduino incorporation or Arduino company as a whole is Massimo Benzi and David Millis. Okay, and their friends along with them. Okay, they came up with the idea of solving certain problem in their industry when they are sitting in bar and restaurant while they are having their weekend party, and they started with this idea and they had a goal of solving a very important problem in the process of design and development of any prototypes. If anybody came up with an idea, they have to struggle like anything to develop a prototype in the back 1990s or something, because on that time the technology was not so great as we have right now, and also on that time there is no such a development board which made their process of developing, process of learning, process of implementing ideas are very difficult on that time, because of which these people came up with the idea and their goal was to make it easy. Okay, make it easy and make it easily available for everyone, make it fast learning curve is reduced by a great extent and anybody can learn it at any stage. That's how even we inspired and we created this wonderful course for you. Okay, so this is a brief history about Arduino. There is a huge story behind it which you have to learn by end of this tutorial. I'll come back to that point. Now let me talk about the syntax of Arduino development board as a whole, or Arduino IDE, integrated development environment as a whole. So first of all, I already said we have a 2 important function in this particular IDE. One is all about syntax, one is all about setup, not syntax. Syntax is all about this setup and loop. One is setup, which is helpful for executing certain instructions only once when the power up happens, or maybe when you give a power to the microcontroller inside Arduino development board. Which microcontroller we have inside? It is Atmega 328P. When we power up this Arduino development board as a whole, we will be executing certain instruction which helps us to set up our environment. It's like booting our computer. When we plus that power button on our computer or laptop, we have certain instructions to be executed at the back end, which helps us to bring that operating system in front of us on this screen, right? The same way that boot option in our development board, like Arduino Uno development board, is all about setup execution, which helps to execute certain instruction only once when we press reset or when we power up the entire board. It's like a reset is like a restart on our computer. I hope you can connect it very easily, right? And then if we want to do certain activity, if we want to execute certain functions again and again, we have to write that particular instruction inside loop. The name only indicates, right? While loop is a function which is predefined and it should be present in the entire programming structure or a framework. And in this particular loop, in this particular function, we are going to write a certain instruction which we want to execute again and again. It's like sensing a data from sensor and sending a signal to actuator to perform certain tasks. These kind of codes or these kind of snippets are written inside this loop, which helps to execute certain application by using this development board. This is how the syntax of Arduino IDE looks like. And other than these two functions, you can write your own functions which are so called user defined functions, and you can execute them as per the requirement. In fact, it's absolutely like a C programming and a C++ programming, combination of C and C++. So you can literally learn it in the fundamental of C programming, or if you are very new to this entire programming structure, I don't think so you have to struggle a lot. It's absolutely simple and easy to understand. But do remember these two things. Setup is meant for one-time execution. Loop is meant for executing again and again until you remove the power or you press the reset once again. Okay. So this is how the syntax looks like. Thereafter, we come to the very important part of the entire tutorial. This is all about the instruction set of Arduino IDE or Arduino development board as a whole. These are the basic instruction set, and do remember they are not the only instruction set in the entire Arduino software as a whole. These are the beginning actually. So we are going to cover these different instructions which I am going to explain you right now. First of all, let me talk about a pin mode. Pin mode is a kind of function or instruction which helps you to declare the configuration of a pin. Say for example, assume that I am a microcontroller, which I am not, but still let us assume that I am a microcontroller, and if I have one input which is a sensor, like when we spoke about sensor, actuators and all, so we know that sensors are nothing but an input device. When we have an input device in our GPIO, we need to make sure that that GPIO is configured as an input, which helps our microcontroller to read the data from that sensor and store it and process it based on the requirement. So we use this pin mode instruction to configure that specific GPIO as input or output. So we have two options inside, which is all about pin and mode. Pin is all about the pin which you are configuring, and mode is all about the direction which you are dedicating for that particular GPIO. It may be input, it may be output, it may be input pull up, and so on. Like, there are different options available. Right now, do remember, pin mode is an instruction which you have to use to declare what kind of a GPIO you are using and what kind of that function you are using with that GPIO, whether it is input or output. A small trick in this is all about, if you are connecting a sensor to any GPIO, it is always input, because with respect to microcontroller, it is input always, because the sensor is giving output and the microcontroller is going to receive that input and process that data and do whatever the actions required. So do remember, when you are connecting a sensor, it is always input. If you are connecting an actuator, it is always output. That is what the responsibility of our sensor and actuator. And also the microcontroller is having those GPIO dedicated for certain application and certain sensor and actuator. So when you connect a sensor, it is always input. When you connect the actuator, it is always output. So now let me come to the second instruction, which is all about digital write. Do notice that these instructions are written in a camel case programming. You can see that pin mode, M is capital. When you are writing a two different word, pin is one word and a mode is another word. When you are switching from one word to another word, the first letter of the second word is always capital. So that's how we call it as a camel case programming in Arduino IDE. So do remember, when you are writing these instructions, make sure that you write that capital M. If you write a small m, of course it will pop up error. So don't worry about it. We are going to execute it live in front of you and we are going to explain you. But right now we are going to talk about digital write. Now let us assume that I have connected an actuator to certain GPIO, and by using a pin mode, I have declared that particular GPIO as output device or output direction. Now I need to send a signal to it, right? What is the definition of our actuator? It is all about converting electrical signal into physical quantity. Say for example LED, it is converting our electrical signal into light intensity, which is a physical quantity. So we need to send that signal, right? Electrical signal. That can be done by using a digital write and also analog write. If you want to send a digital value, say for example 1 or 0, if you want to send us digital 1 or a digital 0, then you can use a digital write and mention the pin number, whichever pin you wanted to generate and give it to as an output, and then what logic you wanted to send, whether it is a high or low, or maybe it works as a 1 or 0, because it is a digital, right? So say for example for pin number 2 of Arduino development board, I have connected a LED. LED is actuator, and I made that pin number 2 as an output by using a pin mode instruction, and thereafter digital write 2, high, which will send a high signal to that particular pin. If I write a digital write 2, low, that will send a low signal to that particular pin. Based on that, whenever high signal comes to that particular pin, LED will start glowing, and whenever low signal come to that particular pin, LED will start, stop glowing. So that's why we use a digital write whenever we want a digital output from microcontroller or maybe Arduino development board as a whole. Similarly, if we connected a sensor to that same pin, let us assume that instead of connecting a LED, I have connected IR sensor or maybe some other sensor like digital sensor or analog sensor, whatever it is. When we connected a digital sensor especially, we need to read that data in the form of digital. That's why it is so called digital sensor, right? IR sensor is the best example here. IR sensor is dedicated with having a 1 and 0 output all the time. Whenever it detects object in front of it, it will generate a high signal on the output side or maybe low signal contradictorily, and whenever it doesn't detect anything, then it will generate a opposite of whatever it is generating while it is detecting an object. So if it is generating a high signal when it is detecting an object, then it will generate a low signal when it doesn't find any object in front of it. The same way we call it as a digital signal because it is generating high and low only, 1 or 0. So if we want to read those kind of a signal with our microcontroller or Arduino development board and we want to process it, then we have to use a digital read instruction. Of course, digital read, in the bracket we are going to write the pin where we are connecting our sensor. Do remember, we are using a digital read only with sensor. It cannot be used with actuator. Okay, the reason is sensor will produce the electrical signal which we are going to read it, and by using a digital read, we are reading a signal from sensor. By writing, this is a digital write, by writing we can control the actuator. So whenever we are using a digital write, it is all about actuator. Whenever we are using a digital read, it is all about sensor. Similarly, we have analog read, which is dedicated for analog sensor. Say for example, if you are interfacing ultrasonic sensor, or if you are interfacing, say for example, a microphone, which is absolutely easy way to understand. Microphone will not generate a signal in the form of ones and zeros, right? Because it is not digital, it is analogous. When we are having an analogous sensor or analogous devices which will generate data in the form of analogous, like variable between 1 to 100 or 1 to 1023, something like that, on that time we need analog read option or analog sensor inside, or an ADC, which is analog to digital converter inside. Fortunately, in our Arduino development board, we have Atmega 328P controller which has inbuilt 10-bit SAR ADC, and because of which we can use analog read instruction directly and we can convert that analogous value into digital internally. So whenever we write this particular instruction, do remember we are reading a data from analog sensor. Sensor, of course, because we are using a read, but we must remember that when we are reading a digital data, or when we are connecting a digital sensor, we have to use a digital read. When we are connecting an analog sensor, we have to use analog read. Thereafter, as I already said, analog write is one more function which is used for generating a signal for actuators. But in this particular case, when it is so called analog write, that means it is generating a PWM signal. Okay, what is PWM and all those things you can learn by yourself. There is nothing big in that or nothing complicated. But in short form, if I wanted to explain you, it is all about generating analogous value to the different actuator which require them to operate. Say for example, a servo motor. Servo motor is all about having a degree of motion, a 0 degree, 1 degree, 2 degree, 3 degree, like that way it will rotate itself. On that time, we have to generate a pulse width modulated signal for that actuator to work. Okay, so for that reason we need analog write instruction. So again, analog write instruction is going to generate a PWM signal, because of which we have two options inside that. What are those two options? One is PWM pin, which pin you wanted to generate that analogous value. Again, it is not possible for all the digital pin or all the analog pin we have. It is only possible with a PWM enabled pin which are located on development board. When we come across that Arduino Uno development board, I'll explain you which are the different analogous pin we have, or which are different digital pin we have, and which are different PWM pin we have. So we have to connect that particular actuator to that particular PWM pin, and we have to mention that PWM pin in this particular section. And thereafter the duty cycle is all about the amplitude of the analogous value, or you can say the pulse width modulation has its own on period and off period. So you need to calculate how much on period you want and how much off period you want, and based on that there is something called duty cycle comes into the picture, and you have to write that duty cycle. Usually it is ranging between 0 to 255 in Arduino Uno development board. So if you are writing a 0, that means you are sending a 0 amplitude signal. If you are writing a 255, you are sending a 100% amplitude or 100% duty cycle in PWM signal that you are generating. That is how we are going to use analog write. Thereafter, when we wanted to communicate by using a serial communication, say for example, I have written a certain code and I uploaded that particular code into development board, that is Arduino Uno development board. On that time, if I wanted to know what is happening inside that development board, if I wanted to know what exactly it is executing and what are the results that it is generating, and if I wanted to debug something, then we can use something called a serial communication. And how to start serial communication? We have one instruction for starting a serial communication, that is all about serial.begin. Serial.begin will help you to write the instruction set for the microcontroller inside to start its UART function. Thereafter, whenever you write a serial.println, wherever you write it and whenever you write it, you will get that whatever you are writing inside that double quote. Whatever that information you are writing, you can get that information in your computer screen by using a USB to UART converter, or maybe USB connected to your hardware and all those things. Okay, we are going to talk about these instructions in detail in coming tutorial, need not to worry about it, and I'm going to explain you how you are going to execute these particular instructions and get to know how to debug the things and all. But right now, do remember, pin mode is dedicated for declaring the direction or declaring the kind of pin used for certain application, and digital write is dedicated for sending a digital signal for a specific actuator, and digital read instruction is dedicated for reading a digital signal from different digital sensor. And analog read is an instruction which is dedicated for reading analogous data from analogous sensor. And then we have analog write, which is instruction which is dedicated for generating analogous variable data or analogous variable signal, electrical signal for analogous actuator. And then we have a serial.begin and serial.println, which is used for internal debugging purpose and internal analysis purpose. So these are the very important instruction you must understand and you must practice before jumping into anything else with respect to Arduino development board. Once you understand these specific instruction and where to place them, that is one more important thing. So when we are placing a pin mode instruction, we have to place it only once in setup. Why? Because if I am a microcontroller, I need to be understood that this is a GPIO which is connected with a digital sensor, and I need to make it as input or output only once. If you tell me this one only once, I'll remember that. So these microcontrollers and Arduino development board and all those things are very intelligent devices. They remember whatever you tell them only once. So for that reason, we need to write a pin mode only once in setup. We need to execute that particular instruction only once. If I want to execute any instruction only once, where should I need to write it? Of course in setup, right? Because setup is dedicated for executing only once. So we need to write a pin mode in setup. But when it comes to digital write, analog write, or digital read, analog read, or maybe anything else other than that, it can be adjusted or it can be written anywhere as per the application or as per the organization of the entire algorithm. Again, serial.begin should be written in only setup. Why? Because it is only one time initialization. It's like a booting of a computer. Do you expect your computer to boot once again when you are working on it? Of course not, right? The same way, when you are writing a pin mode, when you are writing a serial.begin, it's one time execution for the microcontroller to understand what all things to be connected with the internal architecture. So that's why we need to understand where to use these instructions and how to use them. Once you understand these specific instructions and where to use them and how to use them, then pretty much you can understand and you can create any kind of DIY project by yourself. Thereafter, you can learn different instructions and you can start with developing a complex project as well. That's why in this entire tutorial, I'm going to focus on these instructions and make sure that you understand them in the end of this entire tutorial. So these all instructions which you have to learn. Thereafter, I have a couple of assignment for you. Of course, you are watching in YouTube and you are enjoying the entire process independently, but I expect you to read a story of Arduino as a whole company and the inspirational story behind it. Just go through that particular story whenever you get a time by going through Wikipedia or maybe anywhere else. I don't recommend a specific site. Whichever you feel comfortable, you can go through that particular video or maybe reading that particular story, which helps you to understand why this particular concept is created. Thereafter, I would like to have one more assignment from your side, which is all about identify two more instructions by yourself, going through arduino.cc as a website or maybe anywhere. You just identify other than these different instructions, identify any two instructions and comment them below in this particular video. I'll be assisting you if you are writing anything wrong or if you are writing anything right. If you are writing something different, I'm going to assist you in the comment section, but do participate in the comment section so that we can get to know that whether you are learning or whether you are exploring a different instruction other than these things. That's all for today. I hope you enjoyed the entire tutorial and I hope you learned the basic instruction of Arduino development board or Arduino IDE as a whole. Thank you so much for watching this particular tutorial. Stay connected, start learning and explore different instructions. Consider subscribing to our channel Linked Frequency. Tune yourself to make a difference.